Okay, example 6. We have a particle that's oscillating with simple harmonic motion. Now, if the question says that there's a particle that's oscillating with this simple harmonic motion, okay, this is very important. This means that we can use all the formulas that's for simple harmonic motion. Where are all the formulas for simple harmonic motion? You can refer to the last two pages of your lecture notes. Those are the formulas that you can use for simple harmonic motion. Okay, so this simple harmonic motion has a period of 2.0 seconds and an amplitude of 5.0 cm. So this is the period capital T, 2.0 seconds, and this is the amplitude x naught, 5.0 cm. Part A, write down the velocity displacement equation for this simple harmonic motion or this simple harmonic oscillator. Okay, I think just before this, you encounter one formula for velocity in terms of displacement. And this formula is actually this: v equals to plus minus omega square root x naught square minus x square. Okay, so they are looking for this equation. So we just quote this equation, and then we just fill in the numbers that is given to us. So first, there's a omega here. Are we able to calculate omega? Yes, there's a formula for omega. The formula is 2 pi over period. So part A, your first step is to find omega because you're going to sub in some of the known values into this equation. So omega is 2 pi over t, is actually 3.1, which is, you can give it to 2SF. Then you just sub into the formula, p equals to plus minus omega. Omega is now 3.1 square root x naught square. X naught is 5.0. So 5.0 squared minus x squared. So this is the answer that they want, a formula for v in terms of x. Then part B, part C, part D, okay, calculate the speed. Suppose we're using this formula and submit the value to calculate the speed at the various position. So part B, at the center of the oscillation. At the center of oscillation, we know that the displacement is 0. Okay, so we sub in 0 inside this equation. Okay, and that's what we get. 5.0 squared minus 0 squared. We work out, you get plus minus 16 cm per second. At the amplitude position, your x is the maximum amplitude, the maximum maximum displacement, and the amplitude is 5.0 cm, which is given. So we just sub in x equals to 5 into this equation. So 5.0 squared minus 5.0 squared, you get v equals to 0. And then part D, find the velocity when the displacement is 2.0. So we just sub in 2.0 into our equation. 5.0 squared minus 2.0 squared. So we work out, you get plus minus 14 cm per second.